Hello, everyone. Welcome to our live stream. It's been a while since we had the last one, and this one today is going to be pretty special. And we are introducing something called Demon. We will talk way more about it, and more than just talking about it, we will be also showing it off a lot. So I'll be joined with Ryan a little bit later. And before we get to that part, let me tell you a little bit more of the service information that we usually do when we are starting these webinars and these streams. So first things first, we launched Demon last week. It is our take at how real-time audio sounds and could sound, and basically entire tooling around it, building on a step. There's a lot of things that we'll be covering today, but the first step is generally checking out GitHub repo. So if you scan this QR code, you can check the GitHub repo. You can fork the repo itself. If you find it useful, we would very much appreciate your stars. People have already started opening some issues, sharing their comments and feedback, and that is super useful for the team as we are trying to build this together with you guys in public. Talking about building in public, there is also our Discord. If you scan this QR code, you can join our Discord community. We've built a couple of music-related chats, music discussions, feature requests, and showcases where people are posting the tracks that have been remixing them with Demon. And also during this presentation or webinar, in the top left corner, I believe, I'm not even sure if it's going to be on the top left or top right, you will be seeing different QR codes for our Discord, for GitHub, and also for the paper where we publish more information about that. So you make sure to check them out and share your feedback with us. For everyone watching us we are streaming this on multiple platforms. So we are sharing this on YouTube, we are sharing this on Instagram, on X, on where else? On LinkedIn, all over the place. So welcome and thank you for joining us. And I hope you will enjoy this webinar with us and learn a lot about Demon. Going forward, so I already showed you the link to the repo, but if you don't have a local GPU and still would like to experience Demon and play around with it, you can go to music.daydream.live and play around with your tracks or the tracks that we are shipping this with. We are building this in public, as I said, and constantly making a lot of changes. So some of these things might break while we are experimenting with them, but we would like you to give it a go, experiment with it, and let us know how you felt about it. If there are obvious things that we should or we could improve for you. Additional thing that I want to share with you. So now you know what Demon stands for. It's the diffusion engine for musical orchestrated noise made by Ryan. Ryan will be joining me in a minute. We also published, basically Ryan published a paper covering a lot of details about Demon, what was contributed to the A step, what makes it different to other engines out there. And today we also have our paper live on Hugging Face. It's also published on archive. So if you scan this QR code and go to Hugging Face, we would appreciate the upvote as we are trying to get more visibility. And also more importantly, we're trying to get a lot of feedback, both for the paper, but also for the technology that we just launched. And to talk more about that technology and to share a lot of stuff that we have, I will invite Ryan to join me in a minute. Yeah, one additional thing. As I said, if you have any questions, drop them in our Discord. You can post them also on YouTube. I'll try to bring them on the stage as we are going along. Let me see. Yeah, we already see some of them, so that's going to be awesome. So I'm pulling this off. I'm adding Ryan to stage. Ryan, what's up? Can you hear me?
Yeah, I can. Can you hear me?
I can hear you and I can see you. Thanks again for joining. It's awesome to hear you here. Ryan, on the inside, for people who I don't know who doesn't know you, everyone knows about you already. So it's awesome to have you with us. I'm going to add stage your screen and then you can hit it up and take it over. Does that sound good?
Yeah, sounds great.
All right. I think you should be good to go. Yeah.
Cool. Let's confirm you can hear the audio. Can you hear that?
You're good. Yeah.
All right. Cool.
Yeah, you're good.
All right. What's up, everybody? Thank you, Vibber, for asking me to do this. I'm really excited to be talking about this project. I have like a loose sort of mental model for what I want to talk about here, but it will be, mostly improvised. So anybody feel free to jump in, at opportune points with questions. And I'll do my best to field them. So for those of you who don't know me, I've been working with the Daydream team for like I think almost 2 years now on real time AI, and they found me in the Comfy UI community. So I've been doing like generative stuff for several years, and then got into real time with Daydream, and did some work with real time AI video, and now we're giving audio a crack. And this is really exciting for me because I am a musician. Directly before working for Daydream, I was doing music as my job. So really exciting for me to have this intersection of my two favorite things. So like, what the hell are we doing here? What is Daemon? Like, who cares? Why do we need real-time AI audio? And the reason is basically twofold. Creating music is inherently real time. You need instantaneous feedback when you strike a key on your piano or a string on your keyboard. So if we want to actually make music with AI, it needs to be responsive. Whereas most AI music stuff, you give it a prompt and it gives you a whole song. It's not, the creative process is different from the conventional process for a conventional musician is. So it's inherently real time. And the other reason is philosophical, and it sort of blends with that first reason. To actually create music, we need lots and lots of to actually approach craftsmanship to whatever extent that is possible with generative AI. We need lots and lots of knobs to turn. So having lots of knobs to turn in real time sort of approaches a conventional songwriting thing. It's almost like an instrument. And I'll talk a little bit more about it. There's like, for comparison, the other thing that there is that sort of is in the same ballpark as this is magenta real time, also known as Lyria, also known as infinite crate. And I'll get into some of the reasons that this is a little bit different. But fundamentally, what I'm going to show you here is taking an input song and then remixing it in real time with generative AI using this MIDI keyboard to control it. And after I do a little demo and walkthrough of this app, I'll tell you how we're doing that, I suppose. So I've selected a loop of this lo-fi track. This came from Suno. And I'm just going to let the loop play through one time so you have a frame of reference, and then I'll just start messing around. So here you go. So I was able to get from this lo-fi track to like hardcore dubstep. And my movements were a little bit jerky here, but it is possible to smoothly get from one sound to another sound to another sound. And this isn't like academically infinite, but with a loop, a simple loop, it really it almost is. So that's one example, going from one song to one style, but this can do any style. And maybe I'll go through some of these controls to sort of explain how I did that. Strength, some of you may be familiar, it is actually denoise. So this truncates the schedule, and you can think of it either as how much of the input song is allowed through into the output, or how strong the model is. A strength of 0 means that it is the entire input song unaffected, makes it through into the output. And then a strength of 1 is fully creative. You give full creative license to the model. So these are like the 3 core knobs here. So this is like the overall strength. And then the structure is like guiding the model. So you can let it be maximally creative, but guide it with this structure. So you might have noticed that here, I'll just fire it up. So here we'll preserve some of the melody and the beat. But when I turn structure all the way down, it's essentially a different sound. So it's essentially a different song. It has no guidance except the initial noise, which is coming from the input track. So we've got the input track, and then we have structure and timbre, which are both guides. So the most creative, the furthest from the input song that you can get is by having strength all the way up and structure and timbre all the way down. So it's basically no guidance at all. So these are like the core knobs up here. And if you master these, internalize what they do, you can start to use all the other stuff. And you get to know how things interact. And it really is like playing an instrument. So I'll go over some of the other core buttons and knobs here and explain some caveats. We have seed. This will just sort of randomize things. So it's a random starting point for the model. This is the input track that we're remixing. This is the timbre reference, and right now we're using the input track. And this is the structure reference, and right now we're also using the input track. But you can use any track. And when you start to swap these out, like here, if we use a thrash metal track, it should get heavier, theoretically. Okay, so when you're going from something heavy to heavy, it's a little less obvious, but you could hear that it did pick up a different feel on the drums. When you can start to mix and match these things and get like highly custom results just from switching around these input tracks. So I'm using stuff from Suno here, but you could imagine using your actual songs or pieces of your own music, or remixing songs that you like, and getting something highly custom by mixing different songs together. So this is like the core stuff here. All of these things have an outsized impact on your output. There are other things that we can use to guide the model, such as the prompt, LoRAs, and then these weird channel things I'll talk about in a minute. So we've got 2 prompts here. You can blend between them, so you can like smoothly get from one idea to another, or like have some sort of dichotomy. And we've got LoRAs, and these LoRAs are like adding it's like adding a style to the model. So the reason we're getting funky death step is because I have a funk and a death step LoRA, but you can use any style that's been trained into a LoRA, and we have a whole bunch here for you to try. In fact, let me try to open a different thing I had saved. There we go. switch this to paper cloud track. For instance, in this example, I'm using ambient and funk. I'm really in a funky sort of mood. But you can guide the model and change the style of the output additionally with prompts and LoRAs. With prompts and LoRAs and timbre and structure, we're throwing a lot of guidance at the model. So they really compete with one another. And remember, the most creative that you can possibly be is with full strength and a minimum of guidance. So the most impactful a prompt can be is when there's no other guidance. I hope I'm explaining it okay, but and that's intuitive. But the model can only be pulled in so many directions at once. So really, it's like a balancing act, and this is sort of where the craftsmanship shows through. Is like you can balance these things in such a way that you get a particular output. Like I'm well practiced with that death step LoRa, and I happen to know that with the death step LoRa at above a certain threshold, these two channels together make it turn it into triplets. It makes the model output triplets, and it's a very distinctive death step sound. So this is something that I've learned playing with this, and it's really akin to like learning an instrument. So these other knobs, I don't know how deep we need to get into this stuff, but steps is quality, ring buffer depth is, and I'll tell you about that in a moment, but this is like a way for you to tune how responsive versus how smooth the system is. And then channels, this is like a research preview. We're just yanking the model around, basically. So they all do very cool stuff, but they are unclassified, meaning that it's just it's difficult to classify what they do at a high level, given that different LoRAs make them behave different ways and different input songs make them behave different ways. So those are like the main knobs. I guess I'll show you another demo now that I've just droned on. I don't even know what I just said just now, so I hope that it made sense. But let me show you another demo, and this one will use a different input song. Okay, so here is the actual song.
Need much more. Head in a paper cloud, moving quiet, moving proud. You ask me where I've been, I just smile and lean in. Window glass, slow rain, my thoughts drift off again. Shoelace on the floor, I don't need much more. Head in a paper cloud, moving quiet, moving proud. You ask me where I've been, I just smile and lean in. Window glass, slow rain, my thoughts drift off again. Shoelace on the floor, I don't need much more. Head in a paper cloud, moving quiet, moving proud. You ask me where I've been, I just smile and lean in. I float past the noise, past the wants, past the choice. Hands in my hoodie sleeve, let the day just sleep. Paper cloud, paper.
All right, sick. So I got that from Suno just before this. So I've actually never played with this song. I really like how it changed the feel slightly. But you could take an input song that has lyrics and overlay them back onto the instrumental. So in that case, we were diffusing just the instrumental without the vocals and then pasting the vocals back on. So you can do like a lot of different things. You can remix an input song and change that song, but keep it sort of materially similar, even enough that you could put the original vocals on top of it. Or, as I did with the previous example, you could get something brand new that doesn't match the input basically at all. So we've got like infinite and there's like almost infinite combinations of stuff. I didn't even demo all these other things, but they all do cool stuff. So before I go on to like explain how this is happening, if anyone has any questions, I could take them.
Yeah, Ryan, we have a couple actually. I'll bring them on stage, but I'll also read them. So the one that was just related to what you said, can Daemon create music, or it's just for fine tuning or remixing existing music? You showed a lot of high level degree of control over the stuff here, but can it be used to start something from scratch, and how would that work?
That's a great question. So, like I did just sort of, I get what you're saying. So you can get something totally different by cranking, you know, turning the structure all the way down, turning the strength all the way up. But like, there's two ways that I can imagine also achieving what you're talking about. One would be, we have like text to music, and you generate that song right here. Instead of what I did was generate it on Suno and download it. You know, we could add this feature where you type a prompt and you get your starting point. And then there's another entirely different approach, which would be where that text to music thing is like embedded here. So we're not doing a cover anymore. We're just changing the parameters of this text to music thing all at once. So the former will definitely work. The latter is a really interesting idea, and I haven't tried it yet. Because like one of the, I'll get into how this works later, and it might be intuitive as to why the latter may or may not work. I hope that answers the question.
I think it does, because Sam Music short, they sent like a positive emoji, so I think we're good. Another question. There are a couple of questions. Would you like to take a couple now, and then you can go to presentation? I think they're contextual here. So Tomas asks, so Daemon is pretty neat, not gonna lie. So it takes a song, splits it by stems somehow, or uploading a custom song is not allowed, only pre-processed or split up songs available through remixing. Maybe while at this question, you can also talk about stem splitting. I know that you know we have this ability. Yeah, maybe talk a little bit more about that.
So the stems, we split the vocals off using Melformer. And so here I've just selected a song from my computer, and I can select a segment. So we're going to use this section, and then this is the inference source. So no matter what, we're going to split your input song into vocals and instruments, and maybe other stuff in the future, but vocals and instruments. And then we can pass something to the model. We can either pass the whole track with the instruments and the vocals. We can pass just the instruments without the vocals, which is what I was demoing, or we can pass just the vocals, and you can get some really weird stuff if you do that. So we split them, and this inference source is what we send to the model. I'm not going to complete this, but we when you upload the song, we'll attempt to detect the key and the BPM and the time signature and stuff, but you can set that here. So you can use any input song, and you can use the stems if you want. Yeah, I hope that answers it.
I believe it does. And while mentioning the beats, there's a question related to that. So if I use a source only, a drum kick beat in 4/4, will the inference create music around it if the structure and timbre knobs are low?
That's a great question, and I can tell that you understand what I was saying earlier. So that's great. Yes, if you have timbre and structure turned down really low, it will create music. Even if you give it just like silence, it will. If you turn the strength all the way up, it will hallucinate music. The output, the quality of the output that you get is dependent on the quality of the input. So to some extent. So if you keep that in mind, I did try, like one thing I wanted to try was like writing a song in MIDI with like the default MIDI instruments in Cubase, and then uploading it and keeping the structure high but timbre low. I wanted to see if it would like complete the song for me, like mix it and make it good. I haven't yet tried that, but it would be a cool experiment.
couple more questions, and then I'll let you go. Talking about the different use cases and the one that you just described, Justin Lucas, what are the use cases you imagine for this? Is it for musicians or non-musicians? Is it for live performances or better for video/recording? I mean, this is a question that we keep asking ourselves like literally every single day. If you want to share with others as well, your thoughts.
My thoughts are like, this might be too ambitious, but I say all of the above. This really feels like playing an instrument. I've done a bunch of touring. Like I'm a performer. Preparing for this little demo here, it was like practicing. I had to practice and like make sure that, I'm not one to really practice very much at all, but I did do a dry run, just like I might with my band or something. So I do see it as something that you could use live. I think it'd be really cool. I also see it as something that a musician could use in their bedroom, like a bedroom producer. We're working on a VST, so it will work directly with a DAW like Cubase or Ableton or whatever. So I also see it useful there, because with audio, real time, unlike video, with audio, real time is important no matter the context. Like it needs to be real time when you're by yourself. It needs to be real time when you're on a stage, because it is inherently real time. So I see it for both performing musicians and studio or bedroom producers. And I also see people having fun with this, like non-musicians, like at a party. We could make an app that's got one knob on it, and it's like takes Spotify input and you turn the knob and it like makes it heavy, dude. Like that would be the first one that I would do. It's just like the heavy knob, or you could make it as complicated as you want, but like infinite DJ. So I see use cases for all of those things, which is one of the reasons I'm really excited about this. So thank you for asking that question. If I left any out, Vibber, feel free to add them.
I suggest we move on, and you guys keep asking questions, and then in the end, our Ron will go through the rest of them. So Ron, you can go ahead, and I'll keep fielding the questions from the audience.
Okay, all right. So the Claude made this. And so some of it or all of it is going to be bad or incorrect, but I'm just going to use it to sort of to guide me here. So as Vibber said, we've got diffusion engine for musical orchestrated noise, and it's like, what is it? We've made AceStep 1.5, which is a batch music model, meaning you give it a prompt and it gives you a whole song. We've made AceStep 1.5 so absolutely fast that you can you can generate these songs and adjust them and fast enough for instant feedback. So if any of you are familiar with stream diffusion, this is essentially stream diffusion, but for audio. So stream diffusion, one of the key innovations that they had was their batched denoising. They call it stream batch. And so they've got a ring buffer, and let me back up. Stream diffusion takes an input image, denoises it really, really fast, and then gives you an output image, an AI image. And it does this so fast that it becomes video. So one of the ways, their key contributions was this batch denoising with a ring buffer. So they denoise like 4-8 images at once, and it takes advantage of the GPU and adds temporal consistency and makes it very, very high throughput. So Daemon takes this concept, but instead of stable diffusion with images as input, it's AceStep with whole AceStep songs as input into this ring buffer. And I was demoing with like loops there, but it can do I tested it up to 4 minutes. So it'll, the throughput goes down, of course, with longer songs, but that's the gist of it. We have stream diffusion for audio instead of images. We have whole songs. So kind of a funny to me, it's kind of funny, and a lot of fun. But that's basically how we're doing it. So with the ring buffer, where we stack the songs together, and I mentioned this in my walkthrough before, you get different properties with different ring buffer depths. So with a depth of 8, we're stacking 8 songs. All right. And so when you update a parameter, it's got to walk its way through that ring buffer. So, but it produces more generations per second. So when I said that it's a trade-off between update latency and smoothness, that's what I was talking about. With a higher ring buffer depth, you get more generations per second. So if you sweep a parameter, it sounds smoother. But it takes longer for your parameters to walk their way through the ring buffer. So a nice sweet spot is a depth of 4, because you still get 11.3 songs per second, and the latency is like cut in half. With a batch of 1, with a ring buffer depth of 1, which works fine, especially for discrete updates, one decoder tick is 81 milliseconds. So this ring buffer, and when I was doing this, it got so fast that, and it was actually working, that like, what's the other thing that's missing besides throughput to make it real time, to make it feel like an instrument? It needs to be responsive. So this is ring buffer depth amplifying the parameter latency, is another problem that I attempted to solve and did to varying degrees. So heterogeneous denoise scheduling. Each slot in the ring buffer has its own time step schedule. So this actually allows what I was talking about, where you make an update to denoise and it will filter through the ring buffer smoothly without deleting the ring buffer and starting it over. So this will like improve feel and onset, but it's still kind of slow, and it's dependent on the ring buffer. There's another thing, which is this shared mutable per step state. So some of these parameters we can manipulate per step, so they are consulted from within the ring buffer, unlike denoise, which is not per step, and thus it cannot be consulted per ring buffer slot. There are parameters that can consult some shared state. And so with that, we can bypass the ring buffer drain entirely for certain parameters, which is really fun, which is really cool. So I attacked a couple of things to make it more responsive given the ring buffer drain. And then one of the other cool things that I did here was a windowed VAE decode. So we've got the stream diffusion style batched denoising. We've got TensorRT mixed precision, and then we have this windowed VAE decode. And all it is I found the absolute smallest sliver of one of these songs that we can decode from the latent space. And I found that with this small sliver, it's identical to the same sliver of a full denoise song. So instead of decoding the full output from the DIT, we just decode the slice that we need, and it's like less than a second of audio. So those are the things that make the throughput and the responsiveness possible. And so I mentioned before that the only sort of comparable thing here is maybe not the only, but the most prevalent thing that's comparable would be Lyria or Magenta, or Infinite Crate. So the difference here is like brass tacks. Lyria is auto-regressive and Daemon is not. That's like the actual difference between the two things. The practical difference is that with an auto-regressive model, which is working on these chunks, when you make an update, it's very difficult to see within that chunk, just like my ring buffer. But their chunk is much larger. Lyria's is 2 seconds. So you make an update, and we're talking 2,000 millisecond response time, which is brutal when we're talking about trying to play it like an instrument. There's also fewer ways that you can control it. Whereas with Daemon, we have all those things. I have a lot of staged features, more knobs. Like my philosophy is like we need more knobs all the time on everything. So there's a lot more knobs coming in addition to what you already saw. And so, but one of the limitations of Daemon is, like I mentioned, it's not academically infinite music, whereas Lyria is. It infinitely produces music forever. With Daemon, we simulate that by using a loop. But when it comes to performing, I mean, that's fine. I think that's probably fine. And you can get so far from your input loop continuously that it really feels and sounds like infinite music. So Lyria's got some advantages, but and they likely approached it a different way than like with a different mindset than I did. But that's the real difference in what Daemon is bringing to the table. It's meant to be like maximally controllable and highly responsive, like an instrument. Do I have another slide? Oh yeah, it runs locally on a consumer card. That really belongs on the previous slide, because Lyria runs on giant cloud TPUs. Magenta, they do have a local model, which I did manage to fit just barely on a 5090. Daemon will run on it's tested all the way to a 3090 with 24 gigs of VRAM. A 4090 is a little bit better, and a 5090 is a little bit better than that. I'm using a 5090 here. 4090s are basically fine. 3090 is about half the performance of a 5090, but it still beats that 2 seconds. So what is actually on this next slide? Yeah, so we're using Ace Step here, and I did confirm that if you were to produce this song all at once in a batch versus how we're streaming it out with the window decode, it's the same. This other stuff doesn't matter. Yeah. So I hope that makes sense. I hope I didn't talk for too long just now.
No, you're good.
Any questions?
Well, there are quite a few. So let me first cover a couple of things. So there were a couple of questions here. So someone was saying VST would be great, and then there was an ask, where can we sign up for the VST? You actually can. There is a little QR code that I pull up just on the screen. If you scan it, there is a wait list for the VST. So you can easily go there and sign up for it, and then we will be reaching out to you. But I also think that Hunter from the team told you guys that you can just drop in our Discord and we'll hook you up. So if you have any questions around that, VST is coming. We are very, very much interested in talking to you and trying to understand what is it that you're looking for to get from the VST. Ryan, another question. You talked a lot about the speed and performance. There's a question for real time. Does this mean that the model has to be small to be fast enough? This one is like what, 1.5B, but there is also a larger 5B version. Can you talk a little bit more about those?
Yep. So this is we're using Ace Step Turbo, which is 1.5, which is 2 billion parameters. Ace Step XL, which is 5 billion parameters, also works within 24 gigs of VRAM. So one thing I didn't mention is that VRAM scales with the length of the input song. I went up to 4 minutes. With XL, it still worked on a 5090, but it gets a little bit sluggish, man. But if you use it's still nice and responsive with XL with a 60-second clip like what I was demoing here. So for the use case of doing loops and like traversing through loops, it works perfectly fine. I forgot to mention this. Speaking of, this is currently built only on A step, but I am working on Stable Audio 3, which is even faster and smaller. So your question was, do you have to have a small model? No, both of the A step models, I guess it's relative, right? But if this conceptually, you could do this with any size model as provided you have enough GPU. So we could take Suno's model, however big that thing is. If anyone has their phone number, hit them up and get us a copy, and then we'll go ahead and make it streamable.
So talking about quality a little bit more, there is a question someone asks, can Daemon handle 320-bit audio? And somewhat related to that, again, in the quality in the quality side, is how dependent is the audio quality on the source material, and how much of it is limited by the current technology? Like, will it ever break free of that scratchy AI music sound that most of these things have in the background? How do you see that going forward?
Yeah, so we've got basically we have parity with in terms of quality, we have parity with the underlying model. In this case, what you heard here is A step 1.5, 2 billion parameter. Will these base models ever get past the AI audio sound? Probably. I mean, probably. And we are moving considerably faster than the video domain. We need a Will Smith eating spaghetti, but in the audio domain. We don't really have one of those. So another question that was asked is how dependent is the quality of the output on the input song? Mm-hmm. And to be clear, it will take a song that is lower quality, okay, and output something that is higher quality. And if we have time, I can demo it for you. Right. Actually, it's copyright, so I don't know. But there's a video on Reddit and on X of me doing Tom's Diner, and it's from 1990, and the quality is very low, like the audio quality, and it actually materially improves the quality of the audio. Can it handle 320-bit? I don't know. I think that's dependent on A step. I was about to Google it, but I don't know the answer to that.
People can find it on the Ryan on the inside, right? That's on your X. I just brought it up on screen, so if they want to check that video, it's on your X. It's also on the Reddit post. So, guys, you should just head over there, and it should be good.
And I'm not saying my remix is a better song, not at all. I think that Tom's Diner, the original, is the best version of Tom's Diner. But I just mean literally the quality of the audio, just to be clear about that.
Yeah, we're good. There is a really interesting use case here, so I will bring it up on screen. So Troy says, I would love to see this developed to allow me to input a completed track without vocals, so basically just an instrumental, then using a LoRa trained on my voice, have it take lyrics which I provide and sing them in my style.
So this would be very cool. The voice LoRa, I do not have solved. We could talk to Marco about that. He had some ideas, and he did the stemming feature here. So he's thinking the same way that you are. However, part of your use case is solved already, and it's just waiting to be released. But A step will do lyrics. So we can what we have staged to be released is you take an input song and we take the vocals and transcribe the lyrics, and then the model will actually reimagine the lyrics for your song, but using your voice. So one thing that we can do right now is we could train a LoRa on your music, but not your specific voice. It would theoretically take on the characteristics of your voice, but I don't know what would happen if we trained a LoRa with only your voice. I don't think the model will just learn oh, this is what music is. It's just vocals. So I do know that the A step team mentioned on a GitHub comment somewhere that internally they have a model that a version of this model that does individual instruments. I don't know. There's a lot of moving pieces here, but they do exist, and we could theoretically put them together.
To that point, Ryan, Troy just said, like, I already have the LoRa, and it works at reproducing my voice, but I can't get it to work with a source song, only one created with text prompts. So Troy, hit us up. We definitely should talk and figure out how we can make this work. I think that would be a good idea.
You have an ACE-step LoRa trained on your voice? Let's talk after. If you're interested, just hit us up on hit me up on Discord. I'd love to hear about it.
He said he trained LoRa using porting songs with instruments, and it pretty well nailed his voice. So,
nice.
Troy, find our Discord. Basically, don't find it. I'll just put the QR code up there so you can go there and find Ryan instead. And Ryan on the inside should be there, so it should be easy for you to find him. Okay, that's pretty cool. Talking about the Will Smith spaghetti benchmark, someone says basically we can just use thrash metal for that.
Yeah, you're right. You're right. Or like grindcore or something. Yeah. My band is like mathcore, or so it's like exactly what A-step is incapable of doing. So this is one of the limitations. I mentioned some limitations of Daemon. There are many, by the way. There are many. Mm-hmm. If you find new ones, let us know. But we also inherit the limitations of A-step 1.5 or whatever model we're using. And it cannot do accelerando. It can't do it can't really do screaming vocal covers. I don't know. Well, but you're right. That is like the best benchmark. Can it do grindcore? And if so, then it's AGI.
Yeah. So talking about AI and how it affects music and you as a performing artist, there's a really cool question. I'd like to hear your perspective on it. I'll bring it up on screen now. It says, there is a big pushback against AI and music and art. However, this is a combination of AI and art. What is your take?
Good question. So, ultimately my take is that it's not going, like I'm a musician. Suno, A-step, these are now better at making songs than I am. It instantaneously gives you a perfect song from a text prompt, which is like a little bit heartbreaking, but it is what it is. It is what it is. So it's not going anywhere either. So I could either be threatened by this, or I could just wrangle it and do whatever I want, which is what I prefer. I prefer to do whatever I want. So doing whatever I want and wanting more knobs to turn is really what's driving me here. Because if we keep the human being in the process, then what's the problem with using AI? If it's highly controllable by a human being, then I don't see the difference between Daemon and a synth. It's just a new instrument that's in a paradigm that we are unfamiliar with, at least in this way. But the pushback against AI and art, I guess I understand it. I understand where people are coming from, but I disagree largely. It's what is art, man? It's the line is different for everybody. For me, that line is it's somewhere, and it includes a human being. But it really varies, and it even varies by the human being. If I know a human being to be an artist, they could do basically anything, and I believe them. So it's what is art? Is the act of viewing something, the way that I interpret it, is that an art? It's a bullshit question, in my opinion. Anything is what are we talking about here? Yeah, I could go on.
Yeah, so someone chimed in on this one. It says in terms of what the AI generates, it's a perfect compositions, but not perfect audio quality. Producers still have a lot of work.
Even more.
Even more nowadays. Yeah, exactly. Developers have now more work with all the vibe coders and stuff like that. With this, you'll have a similar effect. An interesting ask here. So Vessel Systems asked, hey, just hopping on unbelievable work. what is the best path to utilize all the work you have created? I'm wrapping my mind around all past Reddit threads and whatnot. Thank you for the community. So first things up, I already shared here a QR code. It says try it out. So you can already try this out. Even if you don't have your local GPU, this will run in on Daydream infra. So you can just go ahead and try that out. But from your perspective, Ryan, from what you built with Daemon, what's the best path to utilize this? How can people contribute? What they can do with this already?
I guess it depends on your local setup. There's two paths. One is you're working on RTX. Nice.
Like RTX 46. Yeah, you can see it.
Yeah. So you could just clone the repo, and then if you work with Claude, tell him to set it up. Basically, you just the setup is not bad. It's UV, so you make a UV environment and then build the TensorRT engines. TensorRT is actually not required. It will use Eager or Torch compile. It's just not as good. So simple as that. Just clone the repo and then whip Claude into shape.
It really is that easy.
It sounds easy, but I'm sure something will go wrong. In which case, just hit me up on Discord, and I can help you out.
Awesome. He says it really is that easy. So that's pretty great. Following up on one question that he had earlier, and so you showed separation of vocals and the instruments itself, right? So the ones asked hey, I was hoping stems of various instruments. That would be a really good update. Like vocals plus instrumentals is lovely though, but is there a chance, for example, to change, swap just, I don't know, drums or sax or something like that? How would someone attack that as a problem?
We have to add it. So this is Marco's feature in his domain. I actually know nothing about Melformer. I just know that he's using Melformer to rip the vocals off. I'd hazard a guess that it's also capable of doing full separation, but I don't actually know. But this is a feature that we need to add, and you're not the first to bring it up. So I'd say it's pretty likely that we'll end up doing that.
Awesome. I really think, okay, there was one more that I don't want. I think this might be from Gadi, if I'm recognizing his handle well. Does it take a live buffer, and if so, how big?
It does not currently.
Not currently. Okay. And I think we covered it all. Ryan, is there anything else that you would like to share or some final thoughts? I know that we're running up on time a little bit. It's been quite interesting, and there was a lot of interesting questions. Is there something that you would like to share with others or leave us with some interesting thoughts or ideas of what we should do with this going forward?
I'd really like to hear and see what people create with it. It'd be really, really interesting, and it would help improve. I just personally would like to hear what people make, but also watching that would help us to improve it. I'd also add that this is actively under development. We're furiously updating this and taking feature requests. So if you have any, pop in the Discord. We're all in there, hanging out, and we'd love to just chat about this stuff. Yeah. And I feel like my live demo, I don't know, it's tough to fit everything into one demo, but I mean, you can get just about anything you want out of this. So try it. Just try it, and let me know how it goes.
Awesome. And you said we hang out on Discord, but people from the team are also in this chat, including Marco, who answered your question about stems. So he says, unfortunately, Melbourne Reformer can only do vocals and instruments. We experimented with using A-Step 1.5 itself, but the results were mid. So more research on this front is required to ensure. But obviously, we are working on that.
Yeah.
Marco, thanks for jumping in. This is super useful.
Appreciate it.
All right. Ryan, awesome having you again. This time, completely different topic. Last time, I think we talked about waves and LoRAs in the audio space, in the video space. Now we're in the audio space. Everyone, thank you so much for joining us, for all your questions. This was awesome. Hit us up on Discord, on our socials. We're all over the place. We'll be having more of such events in the future, sharing more content. We are very much interested, as Ryan said, we are building these things. Your feedback, your critique, anything that you're doing with this, we would love to hear it. We'd love to see it and keep improving on that. Until the next time, stay creative, create stuff with Daemon, play with it on music.daydream.live, or just clone the repo, explore with it. And we'll see you soon again. Take care, everyone. See ya.
Thanks. Bye.
Bye-bye.